In this next step, we are going to find this. First of all, we are taking the starting point. Okay. In the next step, we are going to take this our next value at omega c1 5 radians per seconds. Okay. So what's it? Magnitude at omega c1 5 radians per seconds. Okay. So what is that here? The same m1 value is going to find 20 log of k, okay, plus, so here 40, okay, so why it is coming 40? Here s squared is there, so 40, okay, 40 log of, so here 0.1 is there. In this case we are going to find this 5, okay. So what's the answer for this? 20 log of, what is your k value? Which is 20, okay. So m1, here it is omega c1, okay, omega c1, 20 log of 20 plus 40 log of 5, okay, 5 radians per seconds. So what's the answer? 20 log of 20 plus 40 log of 5, okay. So 53.98, okay, we are rounding as 1 decimal, so m1 equal to, so 53.98 I am assumed is 54 decibel, okay. This is my first magnitude value, okay. Then in this next one, see this, here net slope is coming, okay, net slope is coming, so we are going to take the formula as like, so magnitude at omega c2 which is equal to 50 radians per seconds, okay. Here we are not using this formula. Why? Because means here the net slope value is coming, okay, net slope value is coming, here it is not coming, here the net slope value is coming. So let me take this is for the starting point, okay. This is for that your omega c1 value. This is omega c1 to omega c2, okay, omega c1 to omega c2. Then here omega c2 to end point, okay. So we are omega c2 to omega end point. So here we are using the formula. What's the formula for this? Okay, so m2 value is going to find, okay, net slope value from omega c1 to omega c2, okay, net slope value from omega c1 to omega c2 into log of your omega c2 value, omega c1 value plus your previous slope value, okay. Here what is the slope value from omega c1 to omega c2? Here 20, okay. So 20 into log of omega c2 value 50, omega c1 value 5 radians per seconds, previous slope value 54 decibel, okay. So here what's the answer means? So log of 1, so log of 10, okay, log of 10, okay, 20 log of 10 20 log of 10 plus 54. So your answer is 74 decibel, okay. So in the next point we are going to take that omega at end point, okay. So let me take our magnitude at end point. Okay, magnitude at endpoint, magnitude at omega c2, so magnitude at omega c1, so magnitude of the starting point. Okay, so what's it? Our calculation means the same formula. Here endpoint is there. Okay, so net slope value from omega c2 to endpoint. Okay, into log of omega e endpoint divided by your previous value omega c2 plus previous slope value. Okay, so in this formula we are taking this net slope value from omega c2 to endpoint, so which is here 0 only. Okay, 0 only. What is that? Your end point is there, so let me take our end frequency as 100 radians per seconds. Okay, so here we are taking is 0 into log of, what is that, 100 divided by 50 plus previous slope value which is 74. Okay, that is your endpoint frequency range. Here it is 0, so your answer for this endpoint is 74 decibel. Okay, so that's the answer. Here we are calculating the magnitude plot. Okay, so what's our magnitude plot value? So what's our magnitude plot value? Okay, so here I am taking radians per seconds, here decibel per decade. Okay, so my first radians frequency 0.1. Okay, so here what is my decibel per decade value? So 0.1 for that starting decibel, which is minus 14. Okay, then second one 5 radians per seconds, then 50 radians per seconds, then 100 radians per seconds. For 5 radians per seconds, my magnitude value which is 54. For 50 radians per seconds, my magnitude value which is 74, then 100 also 74. So that's it, our magnitude plot. Okay, then we are going to move the phase angle plot. Okay, this is our step number 5. Okay, so how do we find the phase angle plot? Simple. Okay, let me consider the phase angle value. Okay, so what is this? The angle. Okay, so let me take, this is your omega value. Okay, this is the pi angle value. Okay, here your pi angle which is equal to what? 180 degree. Okay, so 180 degree minus tan inverse of, okay, 0.2 omega minus tan inverse of 0.02 omega. Okay, so here your omega value is going to be increase. Okay, so like 0.1, 5, 50 as well as 100. Okay, so let me discuss how do we substitute in this. Okay, phase angle plot. So I am going to take using the calculation.